Welcome to the periodic table, learning with the Boys and Girls Club. Are you ready to get started? I know I am.
And now, ASAP Science presents the elements of the periodic table.
There's hydrogen and helium, then lithium, beryllium, boron, carbon everywhere, nitrogen all through the air with oxygen so you can breathe, and fluorine for your pretty teeth, neon to light up the sign, sodium for salty times,
Magnesium,
aluminium, silicon,
phosphorus,
then sulfur, chlorine, and argon,
potassium,
and calcium so you'll grow strong,
scandium,
titanium, vanadium, and chromium, and manganese. This is the periodic table, noble gases stable, halogens and alkyl react aggressively. Each period will see new outer shells while electrons are added, moving to the right. Iron is the 26th, then cobalt, nickel coins you get, copper, zinc, and gallium, germanium, and arsenic, selenium, and bromine film, while krypton helps light up your room, rubidium, and strontium, then yttrium, zirconium,
niobium,
molybdenum, technetium,
ruthenium,
rhodium, palladium,
silverware,
then cadmium and indium,
tin cans,
antimony, then tellurium, and iodine, and xenon, and then cesium, and barium is 56, and this is where the table splits, where lanthanides have just begun, lanthanum, cerium, and praseodymium. Neodymium's next to promethium, then 62, samarium, europium, gadolinium, and terbium, dysprosium, holmium, erbium, thulium, ytterbium, lutetium, hafnium, tantalum, tungsten, then we're on to rhenium, osmium, and iridium, platinum, gold to make you rich till you grow old, mercury to tell you when it's really cold, thallium, and lead, then bismuth for your tummy,
polonium,
astatine would not be yummy,
radon,
francium will last a little time,
radium,
then actinides at 89. This is the periodic table, noble gases stable, halogens and alkali react aggressively. Each period will see new outer shells while electrons are to the right. Actinium, thorium, protactinium, uranium, neptunium, plutonium, americium, curium, berkelium, californium, isonium, fermium, mendelevium, nobelium, lawrencium, rutherfordium, wm, sprigium, boreum, hesium, meitnerium, dubsidium, rucanium, copernicium, nihonium, flerovium, moscovium, livermorium, tennessine, and organesson, and then we're done.
So what do you need? Your thinking cap, pencil and paper, maybe some index cards, some periodic table knowledge, your lap book for notes if you have one. If you don't, that's okay. It would really be helpful to watch the periodic table part 1 video. And that's it. Come along and let's have some fun. Our objectives today are to understand how the periodic table is useful, where the periodic table came from, and elements' properties can be predicted from its location on the periodic table, and be able to find the location of the elements of the periodic table based on its properties. We learned a lot of this in the video of part 1. So you'll utilize those things that we learned in this video. We'll review some of those things before we start your part. So let's move on. Did you know that alkali metals are on the left, alkaline are in the second column, transition metals in the third, metalloids 13, reactive metals in the green, halogens in the 17th. Do you see a trend? Noble gases in the pink. Take a real good look in this area. All of the blue, light blue, are transition metals. The alkaline metals are in the red. Alkaline metals are in the gold. Reactive metals are in the green. Metalloids are in the light yellow. Noble gases are in the pink. Halogens are just those that are straight down on 17. Really take a good look at this. Pause it and take a good look at it. We're going to move on, but I want you to actually pause it and take a real good look, because you're going to need to know this in something that we're going to work on later. So pause, take a real good look, and then move on with us. How is a periodic table useful? I'll bet you ask yourself that often. An element's properties can be predicted from its location on the periodic table. The periodic table is arranged in 7 rows called periods, from the left to the right, and the properties of the elements change in a pattern. Metals are on the left, metalloids are along the zigzag, and nonmetals are on the right. The periodic table is also arranged in 18 columns called groups or families. The elements in each group have similar properties. Metals. Metals are located on the left side of the periodic table and have physical properties that include luster, malleability, ductility, thermal conductivity, and electrical conductivity. They are solid at room temperature, except for metals. Luster means that they're shiny and reflective. Malleability is the ability to be hammered or rolled into flat sheets. Ductility is the ability to be drawn into thin wires, and thermal conductivity is the ability to transfer heat. Electrical conductivity is the ability to carry electric current. How are metals classified? They're classified as alkali metals. That's group 1. They're soft silver-colored solids. They are the most reactive metals on the periodic table because they have only one valence electron. Remember that, you're going to need to know that. That's lithium, sodium, potassium, rubidium, cesium, and francium. You're really going to need to know those in a minute. But you can come back in the video and look at it if you need to. Okay. Now, how are metals classified? Alkaline earth metals, beryllium, magnesium, calcium, strontium, barium, radium. Those are very important. That's group 2. The elements in this group are all silver-colored solids, just like the alkali metals. They are very reactive, though not as reactive as metals in group 1. Each element in this group has 2 valence. How are metals classified? Transition metals, group 3 through 12, all of these right in here, are less reactive than metals in groups 2. Non-metals, they are located on the right side of the periodic table except for hydrogen, and have physical properties that are dull, brittle, poor conductors of electric current and heat, and low densities than metals usually. Many are at room temperature. What about diatomic molecules? Some nonmetals, 7 of them, naturally occur as a diatomic molecule, which means they have 2 atoms bonded together. This is a single atom. This is a diatomic molecule. The diatomic molecules form 7 on the periodic table. 1, 2, 3, 4, 5, 6, 7. You see all the yellow? That's your diatomic molecule. So what does this really mean? How can you remember 7 diatomic molecules? With the mnemonic device. I have nice closets for brooms. Oxygen, iodine, hydrogen, nitrogen, chlorine, fluorine, and bromine. I have nice closets for brooms. Oxygen, iodine, hydrogen, nitrogen, chlorine, fluorine, bromine. You need to remember that because I'm going to ask that question in a minute. So why don't you pause it, say that over and over and over again, and then come back with me. Oxygen, iodine, hydrogen, nitrogen, chlorine, fluorine, and bromine. I have nice closets for brooms. How are nonmetals classified? Halogens, fluorine, chlorine, bromine, iodine, and astatine. Groups 17. They are very reactive. The elements in this group have 7 electrons. How are nonmetals classified? Noble gases: helium, neon, argon, krypton, xenon, and radon. They are group 18. They are usually non-reactive. Elements in this group have 8 valence electrons except for helium, which has 2. Metalloids. Between the metals and the nonmetals on the periodic table are metalloids. They have some properties of metals and some properties of nonmetals. They are used to make semiconductors, which are substances that can conduct electric current under some conditions, but not others. Semiconductors are used to make computer chips, transistors, lasers. Okay, now it's your turn to use what we have learned. You can go back in this video to look each of these up. Pause the video for each one. All right, let's review. Alkali metals, here. Alkaline metals, the yellow straight down. Transition metals, each of the baby blue. Metalloids, the baby yellow. Reactive metals are in the green. Halogens are actually straight down. Noble gases are in the pink. Okay, now your turn. Okay, let's try the first one. Find the elements that are halogens. Find 4 of them. Stop the video. Halogens: fluorine, chlorine, bromine, iodine. If that was your list, congratulations. I'm very proud of you. Find the elements that were metalloids. Find 4 of them. Pause the video and come back. Metalloids, 4 of them. Boron, silicon, germanium, arsenic. Very good. Good job. Find the elements that have properties similar to tellurium. Find 3 of them. If you said oxygen, sulfur, and selenium, you were right. Very good. Find the elements that are diatomic molecules. Don't forget to pause the video. Find 7 of them at room temperature. What about diatomic molecules? Some nonmetals, 7 of them, naturally occur as a diatomic molecule, which means they have 2 atoms bonded together. This is a single atom. This is a diatomic molecule. The diatomic molecules form 7 on the periodic table. 1, 2, 3, 4, 5, 6, 7. You see all the yellow? That's your diatomic molecule. Boron, aluminum, and gallium. Very good. 3 or 4 alkaline metals. Find 4 alkali metals. Lithium, sodium, potassium, and rubidium. Very good. Find the elements that are non-reactive. Find 5 of them. If you said helium, neon, argon, krypton, and xenon, then you are correct. Find the properties similar to indium. Find If you said boron, aluminum, and gallium, you are correct. Find the elements that have 5 valence electrons. Find 3 of them. If you said nitrogen, phosphorus, and arsenic, you are correct. Find the elements that are the most reactive. Find 4 metals and 5 non-metals. If you said lithium, sodium, potassium, rubidium, fluorine, chlorine, bromine, and iodine, you are correct.
And now, ASAP Science presents the elements of the periodic table.
There's hydrogen and helium, then lithium, beryllium, boron, carbon everywhere, nitrogen all through the air with oxygen so you can breathe, and fluorine for your pretty teeth, neon to light up the signs, sodium for salty times,
magnesium,
aluminium, silicon,
phosphorus,
then sulfur, chlorine, then argon,
potassium,
and calcium so you'll grow strong,
scandium,
titanium, vanadium, and chromium, and manganese. This is the periodic table, noble gases stable, halogens and alkali react aggressively. Each period will see new outer shells while electrons are added, moving to the right. Iron is the 26th, then cobalt, nickel coins you get, copper, zinc, and gallium, germanium, and arsenic, selenium, and bromine film, while krypton helps light up your room, rubidium, and strontium, then yttrium, zirconium,
niobium,
molybdenum, technetium,
ruthenium,
rhodium, palladium,
silverware,
then cadmium and indium,
tin cans,
antimony, then tellurium, and iodine, and xenon, and then cesium, and barium is 56, and this is where the table splits, where lanthanides have just begun, lanthanum, cerium, and praseodymium. Neodymium's next to promethium, then 62, samarium, europium, gadolinium, and terbium, dysprosium, holmium, erbium, thulium, ytterbium, lutetium, hafnium, tantalum, tungsten, then we're on to rhenium, osmium, and iridium, platinum, gold to make you rich till you grow old, mercury to tell you when it's really cold,
thallium,
and lead, then bismuth for your tummy,
polonium,
astatine would not be yummy,
radon,
francium will last a little time,
radium,
then actinides at 89. This is the periodic table, noble gases stable, halogens and alkali react aggressively. Each period will see new outer shells while electrons are to the right. Actinium, thorium, protactinium, uranium, neptunium, plutonium, americium, curium, berkelium, californium, itanium, fermium, and olivium, nobelium, lawrencium, rutherfordium, wm, sprigium, boreum, hesium, meitnerium, dubsidium, rhenium, copernicium, nihonium, flerovium, moscovium, livermorium, tennessine, and oganesson, and then we're done.
I hope you've enjoyed today's lesson and learned a lot. Look for Periodic Table Part 3. Other lessons such as how heat changes the temperature of objects, cool periodic table, real life stuff, what silly putty was really for, and why it all really matters. See you soon.